Go on with this ES6 into the night session. All right, with this new syntax. So a bit to go through, but we might as well start where we left off. So there's a concept called destructuring, which you will see quite a bit. You'll see it in Angular, you'll see it in React. You might not exactly know what it's doing. You may actually get kind of a little bit of an indication of what it's doing. But basically what it does is it allows you to, in a very nice way, extract data from objects or arrays without trying to define them. Basically, you can pull them out and assign them in one statement, and you can pull out exactly what you need. So you may often see this, for example, when we get into something called, routing in Angular or React. Routing is basically a way of navigating your single page application. And you may need to pull it out of a library called core. But core is a huge object that has lots and lots of pieces in it. You don't want to use all of it. You just want to use one specific little thing in there, which is called router. And you just pull it out of there and you assign it. Right at the top of your file, you'll have a whole bunch of statements, and that's where you would define it. So you basically define what you're going to use for your page, and you pull them out. And so you'll see this a lot. It's called destructuring is the academic name for it, but that's what it is. So it extracts properties from the objects and assign them to new constant variables. So you can see here, there's a way we have names where we're basically assigning them cat, dog, alligator. So therefore, we have the constant of those keys right there. We have the values there that are defined. So we pulled them out of the object. Now this example here, you could just pull out, you have that object there, names, right here. We define the object. And we're pulling out everything and assigning it. So we don't have to one by one assign them. We can just pull it all out and it'll assign it at the top. Now we could just use the first one, which is cat, and basically that will be assigned for us, right? When we're using arrays, we can also use it in the same way. Let me get rid of this little overlay here. But when you're using arrays, you'll be using the bracket, right, to pull it out. And you can even use a comma space to skip an item if you don't want to pull those out. All right, so it makes more sense if you actually see it. So if we run this, so we have this profile object. As we know already, we can create objects with key value pairs. Instead of doing something like this, constant name one, because we're already defining it, instead of doing profile by name and pulling it out in this manner for each one, right? Address one, and we pull out the profile with the key, right? Instead of doing it that long-winded way, which totally works, right? City one, but it's a lot of work, right, to do that. And you can imagine if you have 100 properties there, how hard that would be. Instead, we can just walk up to it and just pull it out in this way, right? Even let's get rid of this for a second here. So we can assign things in that way. So if we console log name one, did a lot of work to do that, and we console log name, and that way we should be able to see the difference here if we run it. So they're both the same, but we did this in one line, right? So it's a lot better. So anyhow, it's a lot less work. So it's a way of pulling property values and assigning them in one shot. So you can not only can you do that, you can also do it within objects itself. So we actually had sorry, where was it here? I cut this piece out here. Sorry. So if we want to dig into the object within an object, you can see there that we want to pull out these keys within this object. So it's like a sub object. We can actually target that object, that inner object, and pull out those values so that they're ready to use in one statement, right? So that's pretty slick, right? So if we were to run this, we should expect to get 40 Main Street, which we do. And again, otherwise it would look something like, you know, first we would have to define the address. So we would use the project object, pull in that object like that, and then we would have to, you know, do street, then dig into that object, right? And we'd have to, you know, it's a lot of work because then yeah, I got to look at the keys, I got to try to figure out what they are, and I got to do it for each one again. You know, it's a bit of work, right? So it's a nice way of pulling parameters out and only using what you need. So if I only need at the street out of all of this, I can just pull it out in that way, right? In one line and assign it. And now it's available to me as if I was doing something like this, right? Constant, or sorry, var street1 equal to profile that address. It's the same thing, right? Street, but a lot shorter. And also I don't need to keep digging into the object by key value pair. I can just add a comma and then also pull it out in that manner. So it's a nice, short, quick way of doing that assignment. I'm sure if we took this and looked at the Babel compiler, what it would look like, it would probably look weird because, you know, it does a lot of other work too, but it would probably do the same thing. So there it goes, right? So this profile street constant internally, it actually, to the browser, it looks like that. But for us, we don't need to write all of that. So that's the compilation, right? This is what the browser ends up internally seeing. This is what we're typing on the screen. So again, it's called syntactic sugar. It's sugar for you. It's just different ways of writing programming to make your life easier. You can always revert back to vanilla JavaScript. It's not a bad thing. But just know that this syntax is available to you for modern JavaScript. Oh, sorry, another cool thing that we didn't have before was the ability to have default parameters. So in any major language, we always can have, whether it be Java, I might say strongly typed languages, major object-oriented programming languages, we have default for parameters. So it gives you a lot of flexibility in that, you know, you can create an add function, but if somebody doesn't provide two values, then you can default one. Number one, to avoid that undefined situation. So when it's undefined, you can't do anything with it. You'll often get errors, right? Because then you'll have, you know, you may get an error 3 plus undefined equals, there may be some compiler may not like that. So you're allowing somebody to not pass in the second value. Therefore, if they only pass in 3, then the other value will, y will just default to 3. So if you see on the side here, we invoke it with 2 parameters, 3 plus 9 equals 12. It's great. If we just call it with 3, if this was even called add 2 numbers, it would internally say, okay, well, the second number is not defined. It therefore must default to 3. So 3 plus 3 equals 6. If somebody wanted to break the function and passed in, maybe not intentionally, but passed in 12 and undefined, then this value would be undefined and default to 3. 12 plus 3 equals 15. Default parameters can ensure that you have an empty array or literal, right? So that's always a cool thing. Sometimes you'll find that it's good to do some setup. You know, if the list is not provided, then just give it an empty list. It's good. It's basically a mechanism to allow for default parameters. Nothing more than that, but it's pretty powerful in itself. So we may have looked at some of this already. We may be familiar. So there's a little bit more bonus features instead of just that traditional for loop that we know. And we may have already looked at this. You may not have known that you've been doing it with objects. I think we talked about this one the other night, but you may not have known that it was from ES6. So we can use this for in to iterate over the properties of an object, those keys. So it makes life a lot easier. Also use for in to iterate over the index values of it, something like an array or string, which is great. So previously, what you would have to do is you'd have to do a for loop. You would have to do the for loop traditionally with the index, the start, the expression, and the post, right? Var equals 0. Var I equals 0. I is less than the length of the list, and therefore we must increment it. And as we're incrementing, we're keeping track of the index. As we're keeping track of the index, we're outputting that string or an array. So here, basically, you don't need to use that. You can basically use the for in. So it'll internally understand what you're trying to do, and it'll keep track of the index itself. And if you were probably to take this snippet and look at the Babel compiler, it'll probably translate back down to the for loop that you know. So just a shorter way of doing it. It's really nice because it keeps track of the index itself. So for the string there, it allows you to have that index, and then you can dig into the values of it, which is really cool. If on the other side you're iterating over an object, it'll give you those keys back. So as you're iterating over, it'll give you the make. So as we're iterating over this, it'll know that you have an object here. It'll know that it needs to pull the keys out, and you need to do something with those keys. So make model year, as you're going, you'll console log the make. You using your template literals here, and it knows to evaluate the object via the key. So make Toyota, model, year, and so on and so forth. So it passes the keys back. In terms of a string and array, it'll pass the index back, which allows you to dig into it a little bit more. So a nice little short form. There's also the for of statement. So this one, so again, these are tools in your tool chest. You kind of intermix them based on the type that you're using. You can still do what you know. It's not wrong. This is just, if you prefer to do take advantage of these, you can. If you submit an assignment where you do all vanilla JavaScript and it works, that's perfectly fine too. If you feel comfortable and confident in some of this modern JavaScript and you want to include it, that's also great, right? It's all depending. I'm not going to say which way to go unless I specify it in the requirements. But for like an assignment, it's more about, okay, can you make it work, right? So this one will iterate over the values of an array or string. You can also iterate over maps, sets. So those are other things we haven't talked about: maps, sets, and generators, and DOM node collections. We haven't talked about maps or set or generations. And the argument object available inside of a function. So let's look at this. So basically, we have an array of animals there: chicken, pig, bunny. As we are iterating over them, we basically have that element there. So again, we don't have to keep track of the index. We don't have to keep track of that. It's basically giving us that increment. Same with the string, right? It's basically giving us that character in the string. So it's not giving us the index. The index is in for of, the number value. This is actually giving us each individual element of that string, right? So you may need to use one or the other, depending on what you might need. Now, maybe for of is what you need, because you need that raw element, and that's perfectly fine, right? But maybe you need to iterate over the keys of an object. So maybe the other for loop is better for you because it gives you back a list of keys, right? So it all depends on the object that you're working with, whether it be a string or an object. You can flip back and forth. Now, again, you can go back and do your old school vanilla JavaScript for loop. Not a big deal. If you feel comfortable in iterating over all those indexes and keeping track, totally up to you. For in, for of. There's also for each. I just wanted to mention this because you'll see it somewhere. It's actually depreciated, so it's best practice not to use it. Firefox will now give you a warning about this one. And like I said before, you always need to check the spec of the web documents, right? So again, same deal if we look at the web MDM for each loop, right? for each. Let's look at that one. Prototype for each for arrays. Yeah, so basically if we go scroll down here, it's basically going to tell us the compatibility, and it may give us an issue here for Firefox. Now it's saying some versions of Firefox support it. 1.5, I don't know what that means. 1.5, I've never seen a version like that. So there's some issue with Firefox. It's basically going to complain about it. This method probably has a thumbs down. So again, this is part of your built-in things. You may have come across this already, to be honest. No, I'm sorry. This is a for each on the array itself. Sorry. The for each loop. That's a little different. For each. Okay. Obsolete so here it is right here. I'm sorry. That was for arrays. So this is the for each in statement is depreciated, deprecated. Firefox. Yeah, this is the warning here. Yeah, so this is the one. Sorry. This is not part of the array object. So if you look at this one here, specifications, and then you can see it's basically giving this big red line that this is basically don't use it. So anyhow, I just wanted to mention that in case you come across some of that, some of those. But again, they probably all translate down to what we already know already. Array map. No, that's not that. Let's just know about those. So for each and for in, don't use, sorry, for of and for in, don't use for each. So leading into that, what I had already looked at, now we look at the object and arrays, the built-in methods, which we kind of already know. Some of them weren't always available to us. I don't remember using them. They're like magic to me right now. I love using them, right? It's, if you have no idea how hard it is to keep track of like 2 or 3 arrays and keep them all in sync the old way, oh, it's ridiculous, right? So this, especially if they're nested arrays, it's a disaster. So this is so nice, this stuff. It's like, you know, this is what, you know, the bonus, this is like the premium package here. You could, if you get used to this, some of the stuff, right? This one's a little bit weird, but powerful. It's called the spread. 3 dots. If you ever see it, you'll see it in React a lot. It's basically a way, you'll see it in React if they have a lot of properties they want to pass along. You'll see like the dot operator, 3 dots. Basically, it's a way of copying something and basically, like, here's an example here. When we don't use a spread operator here, you will see in this example, you have an array and you want to put in this other array and you want to put it inside of here. And what would happen was you'll get this situation where you have 1, 2 and the array inside of it, 5, 6. And you would have to iterate through all of this until you hit the middle and then push, like you basically would have to manage 2 array, like an output array, push this in, like you'd have to keep like a stack. And it gets complicated here. You can basically unpack all of that in 3 little dots. And then that'll give you, it'll basically spread it all out internally. It probably does some crazy thing. You know, it probably does a crazy for loop itself to do that for you. But you just take that array and you can combine things and unpack them really nicely. And you'll see the 3 dots a lot, and you'll be like, I have no idea what that is, but it's called the spread operator. So let's look at this thing right here. I wanna take a look at this guy right here. All right. What would happen if we ran this? Well, hopefully it runs, right? All right. So let's forget about this one for now. So if we have array number 1, and we want to unpack all of that, so it's 1, 2, 3, 4. So let's run this. Let's just do array 1 and array 2, array 1 and array 2. All right, so my expectation is it's 1, 2, 3 for the first one, then 1, 2, 3, 4. Right? Uh-oh, array 1's not defined. Okay, missing that. I run this. Arrays are oh, I see, sorry. I have to make sure I name my variables correctly. All right, 1, 2, 3, 1, 2, 3, 4. All right, what in the world is happening there? If I take that back to the Babel compiler, now there's 2 lines of code. So internally, what it does internally is it does something where it takes some array, concatenates So it's really smart, actually. It does this for us. This is kind of complicated, really. Take a new array, concatenate the old array, and then it creates an array around 4. It does a lot of work, right? Like, I mean, it does a bit of work. So you can see how that can get a little bit crazy, to be honest. And we're only starting out. If we had is this a spread operator? All right. Okay, so here's objects now. So if we had 2 objects and we wanted to copy all the properties from one into the other, like so. So we have a person object, object literal. We don't want to write this again. We don't want to use assign and those other, we don't know them, let's just say. We just want to copy these properties in here into object number 2. So we use the spread operator. It's going to copy all those in, and then we're going to add brad.gmail, brad@gmail. So let's console log person number 2 and see what that looks like. All right, so it looks like it copied in those 2 properties, and then it also added our 3rd one. So we did like a hackish version of creating object there. But again, what would that look like if we ran it through the Babel compiler? What would the syntax look like? Well, actually, it didn't do anything, right? It was maybe strict. What's the strict here? If I remove that, what happens? So maybe internally, it probably knows what to do with that one. That's interesting. So that's internal. So that's no syntactic sugar, and that's part of the markup. Okay, that's interesting. On that one, I guess because it's an object, it doesn't do much with that. So that one's interesting there. But all right, so if we take a look at that, so we already did the object, we did the arrays. It probably knows more what to do with arrays more, but it is a bit confusing. So why not we continue on with this one? Oh, I don't want to share it. I want to present it. Right. So the math. So if we want to, so this is a good example here. If you, in the past, I ran into this one a lot. The math operator. So it's math operator is pretty specific, right? If you want to define a maximum value of multiple numbers, and you can't use an array as an input, which is true. You would have to you would have to use the supply method, which you might see and be like, I have no idea why we're using that. You would have to use this kind of crazy syntax here. You'd have to use math.max.apply is null. Why is it null? I'm not sure. It's trying to apply all of the values one at a time to apply to find out the max value in all of this. So it's trying to find 8. So we have to use this weird thing here, right? So basically it kind of applies it one at a time, the max, to figure it out. Whereas we can easily do in one step the spread operator, which basically will unpack everything and run that max against each one of them as it's unpacking. You got to get used to it. It looks a little bit weird until you play with it. But just know, if you see, again, it's knowing is half the battle. If you see those 3 dots, you know it's trying to unpack something. And you just got to, work with it and see how, especially on big objects like React properties or props, especially if there's like 30 of them, you don't want to copy over 30 properties. You just want to use 3 dots, and you know that they're going to copy over and spread out into the next component. My God, it saves a lot of code. So anyhow, let's see what our friend has to say on this one.
Hey,
not this. She's not my friend.
If you're trying to learn the latest in web development, Udemy has a huge selection of online web.
Yo, what's happening, guys? Welcome to your 5th ECMAScript 6 tutorial, and in this video, we're going to talk about the spread operator. Alright then, gang, so the spread operator is this nifty new feature in ES6 that can basically take an array and just spread them into individual elements, and that has a few cool uses. So, for example, let's say I've got an array, so I'll say var meets equals, and we're just going to set this equal to a few meats. The first one I'll put ham, salami, and I don't know, bacon. Alright, so we've got that array of meats now, and if we log this to the console, what are we going to see? Well, let's just give it a whirl. Refresh over here, and you're going to see these meats, ham, salami, bacon, in array form, right? Now, the spread operator is just 3 little dots, and we put it in front of the array that we're spreading. So if I just put 3 little dots like that, it's going to use that spread operator on this array, and essentially it's going to spread the array into its individual components. So let's give that a save and refresh over here. Now you can see it's been taken out of the array, and we see those 3 components separately. All right, so few different uses of this. We'll do a quick example first of all. What I'm going to do is create an array, and I'm going to call this nums1. And this is just going to be a set of numbers, just 1, 2, 3. That'll do. Then I'm going to create another array, var nums2, and I'm going to set this equal to some more numbers. So I'll just say 4, 5, 6. All right, so what if I wanted to add this array, all of these elements, into the start of this array? Well, let's just take a look. Just 1 second. Let's console.log nums2 first of all. Save that and refresh. So currently we're getting this array right here, yeah? So if I just go ahead and pop in nums1 there, what do you expect to see? Well, if we refresh, then we see an array within an array, okay? So this array is the first position, and that's this whole array that's just occupying 1 position in this second array. And within that array we have 1, 2, 3, but I don't want that. I want them to be individual components within that array, so it's just one dimensional, the whole array. And that's where the spread operator comes into play. So we can just spread that array right there using those 3 dots, and it's going to take that array and spread it into its individual components. So now if I refresh over here, we get that one-dimensional array with that first array spread at the beginning. Pretty cool, right? So let's do another quick example. What I'm going to do is create a function which is going to add some numbers. So I'll just call this add nums, and it's going to add 3 numbers together, a, b, and c. So we need to pass 3 numbers into this function, and what it's going to do is just log to the console the addition of these 3 numbers, a plus b plus c. All right. So let's again create a variable which is going to store an array. So I'll say var nums equals, and it's just going to be 3 numbers, so 3, 5, and 7, right? And we want to add those numbers. Now, we want to pass those numbers through to this function, and we can do that really easily using the spread operator. So if I say add nums, if I was just to pass in this nums array, well, it's not expecting that. It's expecting 3 variables, 3 numbers to add together. So it's not expecting just one array. And if we save this and refresh, then we're going to get this undefined right here, right? So what we need to do is instead use the spread operator before that. That's going to spread this array out into its individual components here and pass them through to this function. So now instead we're going to get 3, 5, and 7 in the A, B, and C slots. So let's save that now and give it a whirl, and we get an unexpected token, and that's because we've only added 2 dots. Alright, so 3 dots, and now we get 15, which is the total of 3 plus 5 plus 7. Pretty cool, right? So that is the spread operator, and we put it in front of an array or an iterable object where we want to spread the array into its individual components. Okay? Any questions? Feel free to ask those down below. Otherwise, guys, I will see you in the very next tutorial.
All right, so that's pretty cool, right? It's again, it's just another tool in your tool chest. You could certainly do it the long way, but it's definitely pretty powerful little thing. We also looked at spread operator. Some things that you may have already come across, and these are already built onto the array built-in objects, but I wanted to save them. I wanted to save them for now because they use the arrow function number 1. But you don't need to write it in that way. But basically, it creates so you're able. So this is really important, especially if you wanted to transform some data. If you wanted to do something with an array, and you wanted to, for example, multiply every single element in that array by 2, and then output a new array. So with array map, it basically creates a new array with the results of calling a provided function on every element. So here you can tell in this situation we're using that arrow function here, which basically would be, I mean, we could rewrite that to be function with a parameter of x with a bracket that returns x times 2. That would be a long way, or we could do a nice little one-line function. But if you didn't know what an arrow function was, you'd probably be confused a little bit there. But basically what this is saying is that for every element, I'm going to map each one, and I'm going to apply this predicate to it, this expression, right? So we can transform this value into 2, 8, 2, 8, 18, and 2, right, by applying that to it. Now, this is the way you would so this is array versus a for loop. So if we had to do a for loop here, so you can see here, it's basically using that function instead, same kind of deal. It's basically kind of spread out, it's a little blurry here, but that would be what the full thing would look like, right? Function return, it's the same thing as this line here. But if you look at if you didn't use the map functionality, you'd have to do this kind of thing here. You'd have to create an empty array, and then you just have to use that vanilla JavaScript for loop, keeping track of the index, keeping track of the length, incrementing it, and then pushing the value of that array index times 2, right, onto it, and then you'd have that duplicate array here. So these 3 lines of code here basically are basically compacted into 1 line of code. So again, less code, do more with less code, I think is their tagline, right? So that's map. That was in ES5, so that one's been around for a while. You would use mapping on, like I said before, you might get a data transfer object and you might need to map something across it and transform it in some way. And that's what you would use map for. In the same way, there's something called filter. It works the same way, but instead of transforming each element, you may want to filter some things out. So in this situation here, you have an array of words, and you want to filter out all the ones that are greater than 6. So you want the big words. And again, you can rewrite those in a functional expression that doesn't look like this, but we're using the arrow syntax here. So basically that's going to go through each single element of that string array and compare it. Is the length of it greater than 6? If it is, then keep it. And it returns an array, as you can see there. It keeps those 3 words: exuberant, destruction, and present. So again, if you look in the comparison below here, you could have the function filter, or you could have this section here where, again, you create a new array, and you may have done this in some of your labs already. You create a new array, go through each index. You have an if statement in there to say, is this value, is it even? If it is, then push it on that new array. So it's a lot more work. It's a lot more heavy lifting. And of course, those 3 lines of code with that logic in there, which if you had brackets and all that stuff could be like 6 lines of code, is replaced nicely by this 1 line here, which takes a function. Now, again, this function here could be, you could define it outside of this if it makes more sense to you. Right. So let me just take a look at an example here on this one here, because this one is pretty useful, to be honest, the mapping. If I go to my REPL here and I have a fruit array, and I want to go and console log out all the fruit, well, that's what I could do. Console log out all the fruit. I don't know why I have the index in there. In fact, I could just have that arrow function like this, right? I could wrap this. So if the arrow function didn't make sense to me, I could wrap this in a function like this. The longer way, right, would be to create that inner function inside of there. Already I'm messing up with the brackets, right? Because so that's what it looks like. Function, to be able to spell it. So that's what that looks like, right? It didn't change anything. Well, let's just put grape 1 to know that it worked, right? Right? And also I could define that if that's too crazy for me, I could define, I think I could define this here, right? I could define I don't even have a name for it, right? I don't have a name for it yet. I don't know. I'm gonna just, I don't know, log. I'm gonna log it. It's gonna be a function. It's gonna take a fruit, right? It's gonna do just that. It's gonna console log the fruit. At that point in time, I could just I don't like the look of this. It's kind of crazy to me. So maybe I would just say log fruit, right? Fruit. Is that gonna work? Let's see. Log fruit. Didn't like it. Log each. So maybe I need to use that. So inline, maybe each element goes into there. So why did that not work actually? Maybe it needs to go like this. Log by reference, log by reference, log by reference. I might need a lambda expression, which is really basically defining it then, something like that. Log fruit, right? There you go. I'm missing my brackets there. There we go. All right. Yes. Okay. So you do sometimes need to, if you're not going to have it inline, you need to do this kind of lambda expression because you need to define the name of that element that's going to be coming through. So this has to be assigned in some way. If you're not going to use an inline function, as far as I know, you need to actually define it. We could try to run it by reference again. Will that work? I don't think it will, but let's see. Never know. It did work. All right. So I was kind of 50-50 there. Right. So by reference, it's going to call logger. It's going to basically, it's the same as having that inline. So if that makes more sense to you, that's cleaner, right? It's basically applying this function to every single element in here in one line. So you may have run across for each already. Same as map in a way. But a map, so map will return, let's see, map should return a new array, map. And it may not work, console log. So the map will return a new array, and you can see there it's undefined because we're trying to console log out and it doesn't understand what we want. So it has 3 placeholders for undefined. So the difference between map and for each is for each will run that function on it, and map will actually give the new array out. So yeah, same thing here. So let me see what I did with map. So what did I do with the map function here? So if I have a fruits thing, I want to find a single fruit. What am I going to do here? Let's find the single fruit. No, that's wrong. It should be uppercase fruit. So what I'm doing here is I am iterating across each value. I spelled fruit wrong. Did I spell fruit wrong? And I am uppercasing them all. And I don't know why I'm slicing it there, but I guess I'm grabbing the value and I'm uppercasing it and returning the new array. So I'm transforming it somehow. There's some reason why I did that, to be honest. Oh, I see what I did. Single fruit. I basically removed all the S's and all of those there, right? So you can see here a single fruit instead of plural. I did some transformation where I cut off the last value. I sliced off. Remember we said we can use slice to remove. And then I uppercase it all, right? So if there's too much going on for you, you can basically look at this one here. So apply an uppercase to everything. And that's what that is doing, should be doing. Uppercase it. Fruit to uppercase, there we go. Hey, what's going on here? I have to refresh it now. Oh, there it is, okay. There it is, it did that for me. It just took a little while to come back, right? So this is mapping, and then the other one would be for each. If we looked at for each, that should just output it without the, oh my God, for each. It probably doesn't like the syntax that I had. But anyhow, mapping does that for each, iterates over all of it. Also the filter as well. So if we had an array of objects, so this is kind of what maybe your music application might have, an array of objects. And maybe if you click search, you might need to filter those objects, just letting you know. It might be an easy way for you to find out what you're looking for in your based on your criteria of your music application. If you go to search for like jazz, you might have a big payload like this. You may need to go through all of those and filter only the ones that have jazz out and then keep that list to render. Probably filter would be a good one to use, right? So here we quickly filtered all the IDs that were not equal to 2, but what if we wanted to find the one that was equal to 2, right? Or if we had genre equal to rock, right? I'm just thinking out loud here. Genre, so if this was in fact a music application, hint, hint, right? And this one equal to rock, and somehow in an interface, I selected a drop down where I was just looking for all of the albums and that had a genre equal to jazz, right? That could very quickly just give me, oh, I'm sorry, key value pair. Remember, in your object, you can't use equal. There's a mistake right there, right? You need to use semicolon because it's a key. And then I'm misspelling everything nonstop here. What am I doing here? Person.genre, C live programming. There you go. So again, 2 mistakes I made on the fly there. If you notice, I had equals for the keys, which is wrong because it's a key value pair. And I didn't pick the key I wanted, right? It needs to be the object name. Sorry, I'm iterating over all the objects here. And I'm defining that the current object, which is this one here, when I'm iterating over it, is called person. It could be called, it could be called foobar for all we care. It could be called X. It could be called whatever, but we named it person. It could just be called P. But if we have that object, we need to dig into the key. So the key was genre, and we're checking if it's jazz, right? What I was doing was I was trying to access the key without the object like this, and then it said, the compiler said, I don't know what genre is. It's basically it's not defined, right? So a really easy way of filtering through arrays, filtering through objects, right? So what does this look like if we look in the Babel compiler? What does that look like? Crazy. No, it's not crazy because it's built into it's built into ES5. So it's not that crazy. So it still respects that. I guess if I play around with some of these things, what would it look like? Does it change it all internally? Stage 1, what does that stage 1 look like? Anyhow, I guess because this is pre-ES6 or 2015, it doesn't actually give us any weird thing. It doesn't actually break it down differently for us. But always look at this compiler. Sometimes you'll see some things happening, especially when we get the classes and inheritance. It should, if I'm using the right compiler, give us a lot of thought to what's happening in there. ES5, right? Yeah, that's why. Because ES5 is a lot older. So anyways, there's another one called reduce, by the way. So reduce, so we have map, which maps everything, gives us the array. You can apply something to transform every element. Filter, filters out all of the things we want and returns an array. Array prototype. Proto is something we haven't talked about. It's a way of linking things to an object, but on it, we have this method called reduce. It'll basically give you a single output. So if you wanted to have a way to add all the values up in one way to sum everything, like basically take everything and sum it all up, you could use reduce. It'll go ahead and add everything in there and give you one output. So we had a function there that basically takes current value and I guess what you've accumulated internally. It knows I guess this is the pattern. You could run this across everything and it'll basically add everything up in one shot. If you look at the example below, how you would normally have to do this again is you'd have to define a sum. You'd have to keep iterating and adding and adding and adding and adding to it, right? Again, it's not wrong if that's how you know how to do it. This is just another way to do it if you want to do it this way. So if we look at array reduce should give us a little bit more markup on this. So here's the method here. It's already built in, which is probably why the compiler just knows about it. Probably going to give you some other. So this is the pattern here, right? It takes a function for parameters, current value. So this is the pattern that I didn't magically make it up. It's basically expecting, these 4 values. These ones can be optional, but we included these 2, right? If you look at the signature of it, it has exactly what I passed it. The signature I gave it was the accumulator, and the current, probably it's adding and passing that sum across. It has more information on here. Again, you can read up more on it. It's probably a little bit gets a little bit crazier down there, but that's the pattern. If you wanted to do something like that, you could. Right, so let's get into some other examples on this. You filter with somebody else talking just to break it up. We're almost there. This guy's good, I like Mosh.
Another very useful and powerful method we have in modern JavaScript is the map method. With this method, we can map each item in an array to something else. So following from the example in the last lecture, we have an array of positive numbers. Let's say we want to construct some HTML markup using the elements in this array. So we call filtered.map. And once again, we need to pass a callback function here. This function, just like the function that we passed to the filter method, can have three parameters: value, index, and array. So in this case, again, we're going to work only with the value. So we can pass a function or an arrow function. So we get a number, and then we want to map this to some HTML markup. So we can add a string in an opening list item element. Then we add the number, and finally the closing list item element. So with this markup, we can display each number using a bullet point. Of course, we need to put these inside of a UL element, and I'm going to show you that in a second. So let's see the result of the map method. I'm going to store the result in a constant called items. And now let's display this on the console. So you can see each number is now mapped to a string. That's our list item. So now we have an array of strings. We can use the join method that you learned about earlier to join the elements of this array and create a string. So constant HTML, we set it to items.join, and then display this on the console. Now, instead of an array, we have a string. Note that by default, comma is used as the separator. We don't want to have comma in our HTML markup. We just want to combine these using an empty character like this. Save the changes. Now comma is gone. The only bit that is remaining is the UL element. So a very simple implementation would be like this. We add UL, then concatenate it with all these items, and finally another UL. Save the changes, and here's our HTML markup to display all these numbers using bullet points. Now later in the course, I will show you a more elegant way to implement the same thing. All I want you to take away from this lecture is that we can use the map method to map each element in an array into something else. Now in this example, we are mapping these numbers to strings, but you can also map them to objects. Let me show you another example. So I'm going to delete this HTML. Let's expand this a little bit more. So instead of mapping a number to a string, let's say we want to map them to an object. So here I'm going to define an object. In this object, we want to have a value property, and we want to set that to this number. And finally, we want to return this object. Let's look at the result. Oops, I made a mistake. I deleted the HTML constant, and that's why we get this error. HTML is not defined. So let's display the items constant. Now here is the result of our map. We mapped each number to an object with a value property. Okay, it's very useful when building real-world applications. Now let me show you something tricky here. In our callback function, we are declaring this constant and then returning it. Technically, we don't need to declare this as a separate constant. We can simply put the return keyword here and return this object, because we're not working with that constant, with that object constant, okay? So save the changes, we still get the same result. Now, earlier I told you that in your arrow function, if you have a single line of code and you're returning a value, you can exclude the return keyword as well as the curly braces. So let's do that and see what happens. So remove the return keyword and the curly braces, then put everything on one line like this. Now, if we save the changes, we don't get the same result. We get an array of 3 undefined elements. The reason for this is that by default, these curly braces in an arrow function represent a code block. So when the JavaScript engine tries to parse this arrow function, it thinks here we're defining a code block as opposed to an object to return. So if you're returning an object, you need to put that object in parentheses, like this. So we put this object in parentheses. And with this, our JavaScript engine will not look at this as a code block. Now save the changes. Now once again, we get 3 objects. And one last thing before we finish this lecture. So you have noticed that both the filter and the map method return a new array. They don't modify the original array, okay? Now, these methods are chainable, which means we can call them one after another in a chain. So in this case, this filtered constant is only used here. We haven't used this anywhere else in the code. So we don't have to explicitly store the result of this statement inside a separate constant. We can get rid of this. We call the filter method. Now, we don't want to have a semicolon here because we are not going to terminate this statement. Instead, we're going to immediately call the map method on the result that is returned from this statement, okay? So I'm going to copy our map method here. This is what we call chaining. So we're calling one method. That method returns some result. Now we're immediately calling the map method on that result. Now when chaining multiple methods, by convention, we put each method call on a separate line, and this makes our code cleaner. Have a look. So numbers, dot filter, and then dot map, and so on. And finally, we store the result in the items. That's a better and cleaner code. Save the changes, we still get the same result, right? Now note that here, because the map method is returning a new array, again, we can call the filter or the map method on that array. So here we can call the filter one more time. We get an object, and maybe we want to get objects with value greater than 1. See what happens? Now in the result, we have only 2 objects in our array, objects with value 2 and 3. And again, we can call the map method and maybe map each object to a number. So we read the value property and return it. Save the changes. Now we have an array of 2 numbers. So this is the power of chaining these methods.
All right, yeah, it's really your preference. Chaining is you gotta get used to it. It is very powerful. You might feel like you want to just you know, take the result and assign it to a variable so you can look at it and output it and inspect it. You just need to get used to those. Again, you know, he talked about filtering and then mapping to an HTML element and then doing something with that element. You know, again, if you were working on a music search application, you could filter down this. You could start to build an HTML element for your row. And then you could go and apply that to the DOM, right? You could do that so that you, as you're searching, you're building out your result list in a dynamic way. So you could use something like this, right? You could. Or if you're not listening right now, you'd miss that and you won't. You'll do it the long way, and it would be a very painful experience. So if you're listening to that, then you may pick that up. All right, cool. All right, so let's quickly look at, so there's another way. This is another one I won't really spend too much time. Just, we're not going to really use this one. But just so you know, there is something called a map that you could use, a key value pair. It's just a different way of basically doing similar to an array, but we define our own index. So we're not going to use this in this course. I just wanted to show you that you could research this one. This one is very cool. This one, This one is just a shorthand, and it's I've ran into this many times and been like, why do I have to do this, right? So when the keys have the same name as the variables passed in, so if you had in ES previous versions, if you had a cat and you wanted to name it cat, you'd have to do this kind of silly thing, right? I have a variable called cat. I want to call it cat. I have a dog. I want to call it dog. You have to explicitly be very specific with your key names. You know, you may like what's coming in from that object you're trying to map, and you just say, I want to keep those. Why do I have to map them again? It can get long-winded, especially if you have a big, say, person object and you want to keep first name, last name. So here it's really smart. It'll just know that if you don't give it a key value, it'll assume that that's the key value, and it basically does the work for you. So just a really nice little thing. It's just a quick win, to be honest. Less syntax. So I'll talk about classes quickly because we talked about objects yesterday. We kind of should be review. We kind of already talked about the keywords, but I wanted to at least mention it because it is part of ES6. So we remember yesterday that classes are blueprints. They're basically the template that you need. You know, if you have specification or generalization of a car class, right? It could be color. We have a car color here. We have different objects there that are instances of that class. Once they become an instance of the class, they're now objects. They're a red car, blue car, green car, purple car. They have many forms. They're polymorphic, right? The thing that's similar to each of those cars is they all have a color, because the color is linked to their parent, right? So the classes are the blueprints to our objects. It could look like this. We could have a user class. We have properties in there, right? Attributes, email, name, status, some actions like a login, a log out. Each instance of the object has different attributes to it, but if you trigger a login or log out, they would know how to do it, because that's inheritance working from their parent. So when we get into ES6, ECMAScript, ES 2015. So it basically gives us this syntax, right? If we come from a different background, we could start to use classes. We would know internally what they mean, but it doesn't introduce any object-oriented programming to JavaScript, right? It just in behind the scenes, it does. Like for when we're building it, when we arrange our code, we in our head we're building classes, right? But in behind the scenes in the Java compiler, it does something else, right? So one thing to note is function declarations are hoisted, classes are not, so they're respected more differently. But we can build them out in a way that makes sense to us, right? If you come from that background of object-oriented programming, you'll be very familiar with this. It makes sense to you, right? React uses these quite a bit, actually. They use them, but then I think they realized that maybe it was a bit too much syntax, so then they started reverting back to functions, to be honest. Yeah, it's a bit strange, but anyhow, you will see this syntax. That's why I wanted to at least introduce it to you now. If you come from that background, you can actually create a child class called a subclass, right? So you can use a keyword called extends. So if you have an animal parent class is animal with a constructor. It has an action or method called speak. In here, you can actually create that subclass. You can create a child class that's called dog, that basically has all the attributes of that animal, but now it's a dog, right? Class of dog, but they're all animals, right? It's inheritance. Again, this is a big concept, so if you don't get it right away, it's perfectly fine. If you do come from a background, you will get this right away because it's intuitive. But again, it's just getting you used to the syntax, because we will be using this when we come to React. So it's just getting used to this new syntax. So when you get when you get introduced to that code, you won't be lost. At least on this part, right? Yeah, there's a concept in object-oriented programming where you need to call the parent. So you need access to the parent. You need to let them know something. You know, it's a child class. You need to call the attributes that are above in that hierarchy. So you have something called super. So that calls the super class, not Superman, but it calls it. It'll know internally that, hey, you want to call up one level. You're basically pressing the elevator button to go and level up, and you want to get attributes and actions from that guy up top. So you call super. So if you're at a lower level, you want to access the top level, you call super. It'll know you're trying to change levels and then get access to what's up top, right? Yeah. So again, that's another one too. I'm almost done. Don't worry, I'm not getting too much farther down into this. I think there's one more. There's one more called setter and getter. So in other programming languages as well, you have a class and you just want to set some values and get them. Another feature, again, you may not use it for this course, maybe in React, but they do have this concept of a get and set. This is new. I can't say I've used this in vanilla JavaScript at all. I'm not even really sure, to be honest, if I've used this in React. But I just know about it. So again, you just know about it. So it's basically a syntax that allows you to bind a property to a function, and you can basically, so it is what it says what it does. You get it, you get the latest, you can call it from the outside. So it allows you to have access to that. It makes the object of that attribute public. So outside of your object, you can call it. So you see object.latest. It'll know that it's public, and you'll be able to invoke it in that way. At the same time, set allows you to push some values internally to that object, and you can internally modify what's inside, right? So the person creating this code would allow this, right? I want somebody to access it from the outside, and I want somebody to set it from the outside. It's kind of a design decision. Again, these are object-oriented programming. Attributes, or you may not get it right away, but maybe you might. All right, so an example on that quickly before we go back to our lab, because there is, I think, a couple array questions, and I think there is a, where am I going here? Sorry, I think there is a question on classes. So here we have a person class person. So we're familiar with this from last night. It has this thing called a constructor that allows us to instantiate, pass in a name and value, and set it. And then we have a function. It looks similar to our object last night, I believe, our constructor methods, right? So now we can use ES6 syntax. We can use classes. We don't need those constructor functions if we don't want them. We can use something called classes here because this is modern JavaScript. And it does kind of the same thing. We have that new up person, which is response to this class. And internally, we can call that. So it's pretty much the same thing, just a different way of getting around it, and a different syntax because the syntax is more modern. If I run that, again, it may feel like you're learning a whole new language again, and it is. It's a new syntax, so it does take a little while to get used to, and you may have to switch back and forth. So same deal, we created the class, we created a new object from it, and then we invoked this guy right here, right? If we run that through the Babel compiler, what does that look like? It looks crazy. Look at that. So our syntax here translates to all of this stuff here. It translates back down to a function anyways, and then it creates some kind of crazy key value pair. So anyhow, you can see there's a lot of work going on here. Look at that. All that work, the compiler, it makes me not want to look at it, to be honest, right? So maybe I won't look at it, but I just want to show you it. And what else I want to show you, one thing here was subclasses, right? So we have this person class. Now I want to make a customer, a subclass of the person. I want to copy, the customer still has a name and an age. He still can say hello. So let's reuse this, and we're going to reuse it, and we're going to call a class called customer. I'm going to extend this object so I get all of this. But the difference between the customer and its parent is the customer has a balance, right? He's gone in a store and he owes me money. So therefore he has a balance. Now Now, one thing to note is when you have each class will have a constructor, but you need to invoke this constructor in order to allow the parent to understand the name and age, right? If we didn't do this here, then the name and age wouldn't be known. It would just be the balance that would be known, right? So we need to actually pass up one level name and age, which will go up here and will be set. So now this all works, and then we can focus on this. So again, this is it's a bit of, if you were to draw it out, it would look like a link diagram with the person on top with a link to the customer. It would look a little, you could draw this out and visualize it a little bit better. All right, so anyhow, let's run that. So the person object will not be offended or changed. But now, if we run this here, should run. If we create a customer number one, and we say new customer, his name is Mike, his age is 21, yeah, right. Balance is, I don't know, I owe somebody $500. So if I go and I output customer info like this, right? Okay, customer number one. Let me make sure I run it right. All right. Mike owes me $500. Okay, so I've created this here, and I basically called this one here, right? If I don't call the super here, will it bark at me? It will, because it says you must call the super constructor in a derived class. So it's basically saying that, hey, if you want to use me as a parent, you need to call me. You need to let me know. You need to let me know you're going out late at night on Saturday. You need to let me know what you're doing. So therefore, you need to call me, right? So I need to call the super. Whether or not I give it parameters, let's see. I just need to call him to let him know what I'm doing. So that's fine. So I can call him. He's called, but he doesn't know what I'm doing. So when I go and output the name, it doesn't know anything about the name. We're working at this level here. My parent doesn't know anything about me. It just knows I called him. However, if I want to pass up those values to be known, if I just give him the name, right? Just the name, that'll work now, Mike, because Mike will come in here. It'll be defined as this property right here. So therefore, when I access this .name, it'll see, okay, it's not defined here. I need to go up a level. I'm going to look in this person here, this person object. There it is right there. I found it. So therefore, I'll output it, right? So therefore, I let them know the name. So now the hierarchy of inheritance is working. If I let them know, okay, so that's fine. Because I extended that object, I have access not only to the properties, I also have access to this greet method. So if I walk up to it and I say, all right, customer one.greet, it should say, what will it say? Hello, my name is Mike and I am undefined. And I am. So basically, it doesn't know about the age. So if you notice, it's not going to throw an error. It's just saying that age is not defined. You never told me about the age. I don't know about the age. You passed in nothing. So therefore, I set nothing. So it's undefined. So I would have to walk up to it and say, all right, I'm going to tell you everything to my parent. I'm going to say the name and age. He's going to do his value set those properties. Therefore, when I call greet, it's going to know exactly that, you know, Mike and I'm 21. Yeah, right. So in a way, if that is a long way of talking about inheritance that we talked about yesterday, it's a lot to take in, I'm sure. It's a good example, though. If I run all of this code here through the Babel compiler, we may see a mess of code. This is what it sees. Look at all that. Look at everything that's happening when it compiles down. It compiles down to a lot of stuff I don't even want to look at, right? Crazy. So all that is basically done in this bit of code here. So, all right. So anyways, let's, we're wrapped up. We pretty much wrapped up those the lecture notes. So let's give a little bit more time for the lab before I stop this presenting and stop the recording here for a second. Stop recording.